Okay, my outstanding friends, curious, interested friends, let's discuss NASA explores Earth's magnetic dent. Well, what is a magnetic dent? You can't see that, can you? NASA explores Earth's magnetic dent. Now you can see it. Now, what is a magnetic dent? Well, first of all, I am going to make some statements to sound extremely contentious, and take them however you want to take them, but until you start to examine the nature of particles, I don't care what you come up with for a theory, it's not going to work. Because the nature of particles is that electrons flood the nucleuses and make up the nucleuses of atoms. This would be the nucleus of a hydrogen atom. It would have 1838 or so of these particles. And that would, and then a helium would be this. It would have 7,350 of those particles in the nucleus. And it accounts for every electrical activity, including gravity, including our magnetic fields, including the reason we are overheated right at the moment. Now, we're going to talk about what NASA has to say, and my statement right now is that they're wrong. They're just absolutely wrong, because they just are accepting the things that they were told, which are completely wrong. And I'm going to show you they were wrong, and then we'll go by what they say, and then I will say what I say, and then you will see that I am correct. Right? Anybody not laughing? Okay, my friends. The only way for you to ever understand anything is to understand everything. I mean, really, seriously, and I had to do that, because every step I took, I was being pushed back something. So I said, wait a minute, let me just start from the beginning. What is everything made out of? And I came to the conclusion that everything is made of electrons. It's called electron flood theory. We're going to go through all of this in such detail that I'm sure you're going to vomit. But it's just the way it works. Either you absorb so much that you overflow, or you don't absorb enough to absorb anything. So let's start from the beginning. I have claimed that I understand how the push and shove works with particles. And every bit of physics, 100%, deals with pushing and shoving. It's motion physics. 100% of physics, because when you push and shove, you're forcing in electrons or pulling them out. You're bashing them together or ripping them apart. And electrons, we will go over that. Here's the electron flood theory. And I claim that there is actual layers of atmosphere, and this proves it, because the atomic bomb goes off, its particles go out, and they concuss. Whenever you see something glow, that's concussion, 100%. This is 100% extreme concussion. This is a less concussion, but it is literally particles, bam, slamming into a layer of atmosphere. They're called resonance Schumann frequency zones. They're distances from the Earth, and each one of them bashes into another layer. So there's layers, literally like an eggshell, around the Earth, and that we also see in electrons. In atoms. So you have your nucleus. Now, the nucleus of electron flood theory is all electrons. They're all the same electrons. And these are all electrons too. This is nothing more than a soup. It's just everywhere. They're everywhere. But because of the attractiveness of the core, these electrons, the positives will go to the center, because they can go against each other and they won't have a big problem. Hold on, this is a better illustration. All right, so here, this is a helium. It has 7,350 electrons, not 2 protons and 2 neutrons. It's got 7,350 electrons. Now, the positive sides of each one of these electrons, and an electron has a positive and a negative side, a weak and a strong force. We'll call the negative the very strong explosive force. It glows. That's the thing that's glowing here, is the negative ones. The black part doesn't do anything. The black part, if you could see this, you'd see all the black balls are rolling around here on the outside. They're not involved in this whatsoever. Because I can show that in the light experiments we did. Now, so they don't mind being along with each other, but the white ones want to stay away, so they will always, the negatives will always form a core around the positives. Now, the positives are attractive, though, to more negatives. So once you reach stability here, it says we don't want any more in here. And the positives say, yeah, no problem, we'll just lay in here. But the negatives out here say, oh, there's a whole bunch of positives over there, let's go there. And then the negatives that surround these positives say, yeah, you could come, but just stay right where you are. And what they have to do is stay in these zones like this, away from the core, because the core influences regions around itself, which I think I've shown in multitudes of ways. What does that mean to the energy levels of these particles? If this is attracted very strongly, real close, it means when I pull it away, it's going to go hard. It's like, boom, it's going to go like crazy. Excuse me. This one's the less, and this one will be the least. And those are the frequencies. This one's going to go bzzz. This one's going to go. This one's going to go. This is what well, here they are right here. Now, I also tinkered around with whether they could be different sized particles, but I don't think so. There might be multiple particles in close proximity to the, I would say, let's stay with single particle electrons that surround the cores. You may, when you get in your dense, you know, up in, there's a lot to take into account, mass and numbers, and there's a lot to this. It's not, I'm trying, I know it sounds like I'm making it seem like it's nothing to it, but it's a little more involved. Obviously, you have to know a little more than nothing. But you got to start from the beginning, because if you just accept everything that was said, E equals mc squared, light can't speed up, light can't slow down, light isn't a particle, light doesn't have mass, everything's expanding from the universe because it all exploded from nothing, life is all came from dead dust banging into each other. That's you're lost already. You're just so far gone. If you accept that and you start from that premise, you're done. I didn't start from anything. I always did accept that. So I understood it. And believe me, I never, ever accepted anything anybody told me. You know, just out of hand. And I'm telling you, I found out I was smart to do that, because literally nothing since the age of enlightenment, I'm serious, the age of reasoning, 350 years ago, they said, hey, all those old people, they were all silly fools. And I'm telling you, they tell me that every day from academia. Oh, you're going back to all those things. Those things have all been disproven. Those are all people, all crazy people. I found it's just exactly the opposite. Anyway, just stay with me. You call me fool, call me a bumbling idiot. I don't care what you call me. I am going to show you things in my world cannot be disputed. And one of them is electron flood theory. You can't even make the isotopes. When you go into protons and neutrons, you say, how do you make the isotopes? Oh, well, neutron decays to this and that. Well, a neutron supposed to be the smallest particle. Well, then they start to go on and on and on. And then when they collide stuff at the Large Hadron Collider, they're colliding nucleuses, which have, even helium has 7,350. So they're going to be digging through there'll be 150 particles and 200 particles and 300 particles and 100 particles and 200 particles. And every now and then they'll see a single particle. And that is what they're looking for. And that's all we work with. Rod and I started with light. We started with one of those, a 4-banger. And I show this, you'll see these in so much detail, because I'm done trying to skirt around the edges. I'm going to show you all the pictures that Rod sent me. And I've been years and years of poring over these pictures, trying to understand what we're really seeing. Because he's been absolutely stunning what he's captured. But nobody takes the time to look at it. Well, what is it? It's nothing. It's just a bunch of squiggly lines. But once you take the time to look at it and think about how could this possibly be? What am I seeing? When I see concussion, when I see brightness, what does that mean? What does that consist of? It's a particle pushing against something else, or a field pushing against another field. And what we see, and I have come to the conclusion, it's these, and these are the electron-photon combination. There's electrons side by side, back to back, like two-bar magnets. And when they come flying through the air, being pushed away because of an explosive event like this, they concuss with other particles that are in the air. Now there is a layer of particles right here. We know this, we can see this, because this thing's going bam! And when it does, they glow. Anytime you hit this against something else, you have heat, you have glow, you have luminescence, and the harder it hits, the glowier it glows. Now I can see a layer of atmosphere, and there's going to be another one up here, and another one up and up and up and up. And that's until you get to a point where there is no gases that can push back. You need some form of push back of one of these up here. You need a layer of these up here, because when this comes up, you need one to push back against it. Boom! And then you get your glow. Alright? I hope I'm making sense. I'm trying hard. It's not easy. Okay, my friends, I am just going to lay it on the line today and tell you the whole story between how all this started. I have been deep into quantum mechanics since they coined the term. Now, this was when the turning of the page happened. I've shown this many times. I don't want to brag, but I studied every bit of electronics from the beginning of the Enlightenment era. They realized there was particles and light and different frequencies, and I mean, I did it all, trust me. And then I went into the electronics business, and I was a field engineering manager for a big national, global company. Anyway, and then I had my own business. So I've been away from any academia type of things, or even interacting with anybody else. I sort of stayed on my own. But now, after I retired, I got back into this stuff. And when I saw, now I started floating around the internet, and I saw this picture by Rod Warren. And I was off to the races. And I mean, we are talking about races you would never, ever could imagine. That's light. That's light accelerating. That's a particle that is in light. All of that just exactly totally wipes out Einstein instantly. Now, I can see the particles separating. I can see all of the physics that I did, all of the molecular interactions, how these... I mean, I did this in the deepest depths that you can go to 50 years ago. And my conclusion was, and this is why I got in trouble with my professors, is I believe that it's evident that Coulombic forces are the nature of atomic and molecular behavior. That means they're dipoles. And that means that they are, and here's how this is my theory, is that electrons are dipoles, and these little tiny particles make up the nucleus. There's not just one gigantic positiveness in the center, and then there's some neutralness. I mean, it really doesn't make any sense whatsoever. The electrons would snap together to, they've always come up with all these obscure, innocuous ways of describing things with numbers, and constants. And, little equations that sort of relate to this and that. And they always want to hear a number. Well, there's not always numbers. You can see what's going on. I go for physical truth. I want to see the matter. I want to see what it converts to. I want to see it as it's converting. I want to understand what's happening. So let's go, if you want to stick with me, let me just show you some quick pictures that we're going to be going through, and I have pictures that come out of my earlobes. Hold on a second. Now you remember when the light was accelerating, right here, I'm saying up to this point they were a box of particles. They weren't separated. Once they hit this venturi, the black parts say, I'm not going through there. and they roll around the outside. They say, "I'll come back later, just go through there, explode, have a good time." Now, why do they do that? Let's see what happens here. These are those particles just at the point of impact. You see this? There they are. They look like that. Before this, they had no real definition. There was some energy and some non-energy, but once they started to concuss at the venturi, because the venturi is right over here, then they start to glow, and then they start to crush a little hard. Then they get spikes coming up and down, and then they explode at the venturi and cause the separation of the black from the white particles. Green is just a stronger explosiveness, which means it just has more. It's closer to the nucleus, so as it gets pulled away, it's got more violent impact. The red is further away, and when it gets pulled away, it's less violent of a pull. And then when you get down deeper, you get a blue, and you really got some power. Now, I believe these are coming this way, and as they approach, they start to concuss out here, and they get brilliant before they hit the venturi, and then, like down below, is where the venturi is. You see, they're coming into the venturi, but they get brilliant out here, and they show up as trails of brilliance, and then they turn into a plasma, like the red did. That's what I'm taking from it. All right, first thing I want to say is go to Coursera and look up you take some courses on this, no problem whatsoever. You have to understand how they think all of this stuff formed, and the accretion disks and all these business that they're going to talk about. Now, I explain what my feeling is that the reason these arms are bent backwards is because everything is scrubbing through the particles of space, which is the soup of space that I talked about, or will talk about, the ether. Now, we are going to be somewhere in one of these arms. I don't know where, but let's say we're right here. Let's say we're somewhere up in here. Whatever we're going to come through, we're all moving sort of together, but there's going to be crossings of different places where it's going to be thicker or thinner when we hit it. And we already know this because the resonance frequencies will alter a little bit depending upon what we happen to be crashing through that particular day. And it's exactly what they say. Okay, so this is one of the most mysterious things in science. Why is there Schumann resonance frequencies? How are they created? And why are they at these certain frequencies? Now, as you saw, we are on one of the arms of the Milky Way spinning around literally like this. So here we are on the arm going this way. In addition, we are spinning on our axis. So we're scrubbing through the soup of space. And I'm going to tell you right now, it is a soup of magnetic particles, which is light. I showed this in the electron flood theory many times. Now, if you haven't seen it, you can't hardly miss it if you go to my site. No. So I'm not going to take up a lot of time with this. However, I am going to say, and I have said it before, this spinning on our axis through the soup of space, which is nothing more than electronic magnetic particles. And as we scrub through them, we create a magnetic field identical to this right here. Right, you see that? That's an electric motor. Now, if I put electricity into that, it'll spin. You know how an electric motor works. Everybody knows that. Now, if I put electricity in backwards, it'll spin the other direction. Now, if I spin this manually, which is what is happening with our Earth right now through space, which is these magnetic fields, which there's magnets in here, and this magnetic field, which is in the center, is spinning through that magnetic field. So it's just like our Earth or the Sun spinning through the magnetic particles in space. Watch what happens here. I'm going to spin this right hand. Watch. See that? 1.8, 1 point whatever volts. All right, now I'm going to spin backwards. You can see a negative come up. See the negative come up? So if I spin this way, it's positive. All right, so what it is, we are creating electricity in space, which is our magnetic fields, obviously, and it is also the source of our gravity, because gravity is nothing more than magnetism, and it pulls any single thing there is that has that boson, which I'm going to show you in a second, which is the non-reactive particle. It seems to congeal. That's all I can say. I see it congealing. They might call it dark matter. It might simply be a boson, which they call, and they also call it a muon, and the other part is the electron neutrino. And let's look at that. But don't forget, we're scrubbing through space. That's what's creating all of the magnetic interactions. And it's also creating our magnetic field, primarily. All right, the Schumann resonance is a set of spectrum peaks in the extremely low frequency. So frequencies are pulsations. That's all they are. Pulse, pulse, pulse. Well, what's pulsing? Electricity. And where's the electricity coming from? The electricity comes from, it's generated and excited by lightning discharges in the cavity formed by the Earth's surface and the ionosphere. So here's the Earth's surface. The ionosphere is, let's say, out here. As we scrub through that ionosphere, we are creating electricity, and then it discharges. And then a little more scrub, and it discharges. A little more scrub, and it discharges. Now, as you get closer and closer to the Earth, there will be zones of scrub. And that creates these different frequencies, 7.8, 14, 20, and I know there's 33, and I know there's a bunch of other ones. It's just that those are zones of stability, basically, in our atmosphere. And I can show you that by this bomb. Watch. The bomb displays that there are these zones of stability. All right, this is a channel called At That Moment, and this is about the world's most powerful nuclear bomb, the Tsar bomb. This is 1961, and when you see the atmosphere, you'll see zones that will be extremely excited, and they will look like layers of clouds, and those are the zones, I believe, that are creating the frequencies for the different Schumann resonance frequencies. Now watch. This is horrifying that we are doing this kind of stuff. Absolutely. 57 million million tons of TNT. Now watch the, you know what, here's what I'm going to do. I'm going to put this on slow motion. I'm going to go half speed. Now watch this. Boom. Now, what just happened? What just happened? What just happened is so many particles were so close to each other and already violating each other's regions that they really already wanted to explode like unbelievably. However, then everything gets forced in together at the same time from every different angle, and it just creates an unacceptable region in space that has to push everything away from it as fast as it can. Now, what is it pushing away? Well, it's pushing away molecules, it's pushing away atoms, it's pushing away electrons, it's pushing away fermions and bosons and all kinds of cosmic radiation parts and things. And as they go flying out of there, this atmosphere out here has not been affected yet. It really doesn't know that much about what's going on here yet. We can see it as a big glow because it started. But now this stuff is going to hit the atmospheric layer, and then you're going to see it show up because it excites the water molecules that are in that specific layer, and poof, they pop up and they're shown. Now watch. Absolutely horrifying. Now this is half speed. Okay, so right away, boom, see it? These are layers. Now, there must be zones of stability that are set up by these resonance frequencies of the Schumann resonance. See it? See how obvious this is? Those are particles flowing outwards, exciting the hell out of all of the molecules that are in the air. So what are they made out of, these particles that are exciting these other particles? Again, they're made out of all of the bits and pieces that are in matter. And all matter is made of electrons. Electrons are, in my world, the smallest bits, and that electron consists of a strong part and a weak part. I've shown it over and over. One of them explodes, one of them doesn't explode. And the ones that are exploding are hitting out here and causing this enormous interaction. Now, I got to be honest with you, the world is hard to deal with it in my mind nowadays. These things that we have done and that we are doing, and we've literally ruined the earth. I don't want to go down that road, but let's just get back to the Schumann resonance. There should be a lesson in this, though. I hope there is. And I think this displays why we are getting these different vibrations, because it literally is a layer like if you look up thin film photography, it shows light will come in and bounce off of this layer and this layer and that layer, and it creates different frequencies and therefore different colors. That's what thin film photography is all about. But this, as far as I'm concerned, this shows that we do have a reason to suspect that that's why there's different frequencies set up in the Schumann resonance, because of these layers. Okay, my extremely good friends, this is, get your book, get ready to start writing. We're going to look into the layers of the atmosphere. They are certain layers, and they're exact certain layers, and then they have a pause between them. Why? Why? Well, I believe it's where we're getting our Schumann frequencies from. I'm going to do a little painting about this just so that I can have it in perpetuity. Now, we have the sun. There's the sun right here. And then there's emissions from the sun. What emits from the sun? Well, light, obviously. Some heats us up, something lights us up. Well, I say they're electrons, a lot of them. Other ones are particles that start to form together, electrons back to back, called photons. And then there's also going to be particles, chunks, atoms, molecules. Now, I'm going to do some codes and stuff later and show some equation-ish things. But let's just think about this logically. At the Earth's atmosphere, all right, we know we have gases around the Earth, and then after that there's no more gases at a certain point. So what do we have? At the surface, it's the most dense. It's really dense at the surface. Therefore, 3 dots means the most energetic pushback at the surface. At the surface of our Earth is going to be the most pushing back against the particles. All right, because it's the densest, and in electron flood theory, we'll go over exactly why that happens. They know it happens, and that's why it's the warmest, and they know it's the warmest. We'll read this in a second. Now, the layers actually appear almost hard. And you can see this in the reactions they have to nuclear radiation. I'm going to show you the Tsar bomb. They shot it off, and you see, poof, poof, poof. they like hitting into those particles. Now, what they do is you see them glowing. And what is glowing? Get your book, what's glowing? What you should have this written down somewhere that says, when you see something glowing, it's energetic. So it's something is pushing back. Pushing back is the only thing that creates energy. It's push to shove. If there's nothing pushing back, you just keep going. There's no energy. It's just cruising. But something's going to be pushing back at you because there is light, there's particles, especially in our atmosphere down close to the Earth. Down here, you're going to have a lot of pushback, and then less, and then less, and then less. So as you get out further here, you have less particles collected there, so they're just not pushing. Now, this gets a little bit complicated. It's not bad. So I'm saying, why are there layers? Well, I say it's because they are pushback zones. They're zones that have separated from the positives to the negatives. On one side you have negatives, on the other side you have positives. One's pushing this way, one's pushing that way. At an exact distance. I'm sort of working on that. I'm trying to think of exactly why. But they appear to happen at what they call Schumann resonance frequencies. Now, we know we're not only spinning, and I can show you that, and there's different temperatures, there's different pushbacks, there are all kinds of stuff, depending upon whether you're in the center of the spin at the equator, or where you're up towards the poles, you're just barely scrubbing. Now, all right, and I'm going to show you the spectrum. Now, what's a spectrum? The spectrum is the frequencies of light that are coming into our Earth and our atmosphere. Some of them are blocked, absolutely blocked. You can't get through here. Gamma rays, no, 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 no. X-rays, no, 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 no. Microwaves, no, 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 no. Well, we got a problem because they are going to force microwaves through our area where they're not allowed to penetrate from the Earth. And I show this in the spectrum. I probably already showed it to you. Anyway, just look it up. You look up the top line. It says allowed through the atmosphere, and it says these not yes, visible light, yes. Well, you can have some infrared, but not a whole lot, and ultraviolet and stuff is anyway. So we are going to go over why these layers occur, and I think I pretty much just told you why. Because there's going to be a push to shove, push to shove, push to shove. Now, is that one gigantic frequency? It can't be. These are huge distances. Yeah, I'm not huge, but they're pretty damn big. So what's going on there? Is there a certain number of particles that push, push, push? We're going to have a layer here that is going to be one type, and it's got a negative pull here. As we spin, we're pushing our electrons into the electrons that are coming at us. So it's forcing electrons into the ground, literally. It's forcing electricity into the ground, into our poles. So it will always take electrons down this way. All right? So I would say this Earth is a very positive, attractive force. So positiveness will be surrounding the surface. I think I said negativeness. Positiveness will attract negativeness, which it does. You take electricity, lightning, it used to do that. Now there's so much electrical activity in the air. There's so much over amount of extra electrons in the air that they're trying to go up, sprites and so forth. We're going to get into that. So now, don't forget, this is a positive external. Now here, don't forget, get your book. I got to put this on here right now. This whole outside surface is going to be positive. So I do this, and I put this in here, and I see plus, positive, which is attractive to electrons. It's going to be a positive layer right here on Earth as it spins and scrubs against the other electrons. They appear to be sucked into the Earth, so it's attractive to electrons. Let's just go with that. Now, So we know we have a layer here that's positive. So we're going to have a layer somewhere out there that's going to be negative on the other side of this positive, or how thick is the positive layer? Where does the negative layer start? Is it like 500 of them and then it goes into another one, or does it go up until a certain density and then it becomes stable? Because it's scrubbing now, so it's and they know it does it in pulses. There's a lot to think about here. I mean, there is a lot to think about. I think we're getting somewhere, but you know, there is a lot of places to go with this, and I want to go there if I can. I don't have all the rest of the time that a lot of you people will have to do this, but I'm certainly interested. So if anybody's got anything to add to this, you know, I know people must have a lot to add to this. Anyway, these layers are the pushback layers and the Schumann frequencies, and I think change a lot of the physics of the way we look at particle interaction. And it's all based on the fact that the entire universe, literally, is filled with light. Light is particles. Light are photons. They're either electrons or photons. We're not seeing them. So literally they're dark out there because they're not hitting anything. The only time they hit something is when we see that thing. So they're there. We know they're there because they light up things out there, comets and asteroids and things like that. So, you know, there's no question they're out there. We don't see it. It's just like you don't see them here. I don't see anything there. You see chunks of stuff. So the universe is completely filled with it because they're coming out of the sun. They're coming out of every luminous body. So just get away from this fact that there's nothing out in space. We're scrubbing through that stuff. So it's scrub, 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 scrub. I think what it really does, it's coming back to me. There's a certain charge as it scrubs. It's like a capacitor. It hits a certain point after like a third of a spin, boom, and it like vibrates, and then a third more, boom, it vibrates. It's a number of spins against a number of particles, and the denser it gets, the more interactive it is, and the more it pulsates. But there will be a certain layer that will interact at certain distances as it gets overcharged, and it'll have to pulsate. I think that's what I came up with. So it's almost like a generator. A generator and an electric motor, you know, all it does is it turns on the electricity and pulls something magnetic around to try to meet it or pushes it. Now, that's all this is doing, because we're coming through a soup of particles, and the Earth is spinning into that, and it's all made of electronic particles, and it's pulsating, it's densityness at certain levels, and they fill up and then they discharge. That's why we're now seeing these sprites. There's some levels that are filling up and they're trying to discharge up because the lower levels are so packed now with extra particles. That's called global warming. Global warming is nothing more than too many electrons here. They can't get down into the Earth fast enough. The Earth says, I got so many already, I can't take any more. They say, well, what do we want us to do? Let's just stay out there. And say, yeah, but it's going to get really hot out here. He said, well, what can I do? I don't want them. So eventually we'll say, go up this way. And here's what happens when that happens. They're called sprites. And these are new phenomena, and it's because we're overcharged, is my opinion. All right, here's your sprites. It's actually very simple to understand this with electron flood theory. Don't forget, we have the Earth, we have our different layers of atmosphere. We know that these are almost exclusion zones from each other. Now, what happens here in these sprites, these are red sprites. Now, they are somewhere up in the atmosphere between one of these layers. And the Earth down here just has too many electrons. And they're overcharged here, and they say, I want to go down to Earth like lightning. He says, no, you can't come down here. They say, well, why not? The lightning, you can come down there. And they say, yeah, but we're so overcharged, we don't want you. Go up. And that's what they did. You see this? There's a layer right here, literally. Okay, and that layer is pushing up against those electrons and it's pushing down. That's why we have a glow there. Don't forget, every time I tell you, if you see something glow, that's energy. This energy is pushing against that. That's pushing up against that. That is your next layer down, literally, from between, let's say, this layer and that layer. It's this exclusion zone. Now, so what happened? A ton of extra electricity was here. It says, go up. And he says, okay, we'll give it a shot. Boom! They come up and just slam into the upward going. You see this glow? Look at that glow very, very carefully. What do you see? You see a central core of pop right there. But all around it, basically you're seeing a huge amount of energy going upwards, surrounded by its extra electricity, which really is a spiral of particles. Now, up here, it's accepted too many already, and it's glowing with extreme extra amounts of these particles. All that glow is extra particles, and I mean bazillions of them. Now, this is getting so excited, and it's getting hot, and it's glowing, where it's trying to interact and push into them. Just as it would as if you got electrocuted in an electric chair, and they just explode. Now, so this layer says, wait a minute, pal, you're going to have to go back down. I have so many, I am going to push you down. And it says, all right, we'll go back, but, you know, we'll trickle back. And they do. So you see them coming back down, and that's the trickle. All right, so don't forget, it's a layer in here. One side says, get out, the other side is get back down. It's push to shove. Now, there's so many particles, they say get back down, and they drift back down to where they came from. All right, and it created enough room for them to come back down in here and not be a disaster. Normally, the way it's supposed to work is every one of these layers, and it always did until 25 years ago. They never saw these things until 25 years ago, and they're getting more and more prevalent because the atmosphere is getting more and more charged, and the more and more heat you have here, the more and more electrons you have there, and the more and more electrons you have here that can't get into the Earth, the more they are out here and here and here and here, and they cannot get down. They fill up and they try to discharge out. That's what that is. Now, what does that mean in real life? It means we're never going to get cooled down here that I can see, because we're continuously scrubbing through the atmosphere, and it's not really something we can do much about. You know, we are adding to it by burning fossil fuels, and every time we emit electrons into the atmosphere, yes, absolutely, and that's we were doing a lot of that. And that's what's creating all of these fires and tornadoes and all kinds of weather anomalies that are on these layers are tearing up the atmosphere. All right, so there's my rant for the day. All right, this is just to get your attention. We're going to come back at this in extreme detail. That is light, and it's light non-accelerating. It's a pulsed red laser. Well, once you go to a venturi, that pulse red laser accelerates, and you can see that normally it was just a wave. Well, the particle is like here, way back in the ball of influence. There's no hard boundary out here. We see it as a wave because it's concussing. Here it's concussing. Anytime you see concussion, you're going to see glow. Concussion is glow. This is a reverse wave, and this is a very, very, very interesting, extremely reverse concussion, because we are crushing the particles in this venturi. So this particle was this big, now it's got to fit through this slot, which is a two rounded things that go right in there. They're actually nails, and the light has to force its way into that curvature through that venturi, and that forces it to accelerate, and it forces the particle to pull itself out of the wave. Now, we're going to go into this in such detail that I know it's probably going to be annoying. Now, what we just saw was the wave by itself, the wave accelerating, and here's what happens at the venturi. the little black balls work themselves away. You see those little black balls? You see over here? These ones over here, they're right on top of each other. They don't care about being, it doesn't matter to them. They want to be with the white ones, but they don't want to be with the white ones when the white ones are concussing extremely. They just get pushed out of the way. The white ones just explode like a bomb. So you can see them, eventually they all come back in, and that's why I say these are bosons, they claim, which are the carriers of the strong force. They're the weak force carriers of the strong force. They call them muon neutrinos, and these are electron neutrinos. And again, I will show all this in such detail that it'll be annoying, I'm sure. However, we can see that the charges are separating, and this is an extremely interesting zone. All right, let's go a little deeper.